South Pole. And this is a beautiful image of the lunar South Pole taken by the Lunar Reconnaissance Orbiter. Extremely haunting, really weird landscape. But let's talk about it. So this is the topology of the moon, basically. We've got the near side and we've got the far side. The South Pole is characterized by huge craters, very deep ones, with ridges between their rims, and just on the far side of the moon, and therefore invisible most of the time from us, is this big blotch here called the Aitken Basin, which is either one of or it's the biggest impact site in the solar system, a massive impact on the moon. And we get to see a little bit of it when occasionally when we can see a little bit of the far side of the moon. But as you can see, the near side characterized by a lot of craters and quite mountainous terrain. Now, the actual lunar South Pole is in a very not obvious position. This is looking at the area of the lunar South Pole. And the lunar South Pole is actually exactly here on the rim of a crater called Shackleton, named after Ernest Shackleton, of course, the famous British explorer. And the lunar South Pole is exactly there, literally on the rim of the crater. And the Shackleton crater is 21 kilometers wide by 4.7 kilometers deep. But we've got some bigger ones around it. We've got Hayworth, for example, 51 kilometers, its depth unknown. We've got Shoemaker, named after, of course, the famous scientist Eugene Shoemaker, and 50 kilometers wide by 2.5 kilometers deep. Faustini, 39 kilometers wide, depth unknown. De Gerlache, 32 kilometers wide and depth unknown. So you've got some pretty wide craters here, and some very deep ones. And you can see the ridges here between the craters, and making the whole landscape look really sort of mountainous and big. Now, interestingly, a lot of these craters are in permanent shadow. The sunlight never penetrates them, never illuminates them.
I'm Ernie Wright. I work in the Scientific Visualization Studio at NASA's Goddard Space Flight Center. We're looking at a computer model of the view at the South Pole of the Moon. This is like a time-lapse to show the motion of the Sun and the Earth and how the shadows change over time. Things don't rise and set in the usual way here. The Sun travels around the horizon, never getting more than 1.5 degrees above or below it, so there are always these long shadows. And from here, the Earth appears to be upside down and rotating backwards, but that's just because of our point of view. The Earth doesn't move much in the moon's sky. It's always in roughly the same place, just sort of bobbing around. That's true everywhere on the near side of the moon. It's a consequence of the moon always pointing the same face toward Earth. It takes about a month for the Sun to make a complete circuit around the horizon, and every so often, it'll pass behind the Earth, creating an eclipse. I've slowed down time here a little so that it's easier to see. On Earth, that would be a total lunar eclipse, the moon passing through the shadow cast by the Earth. But if you're standing on the moon, it's an eclipse of the Sun. The terrain at the South Pole is especially rugged. The rim of Shackleton crater is in the foreground here, and the mountain off on the horizon, unofficially known as Mons Malapert, it's about 85 miles away. Shackleton crater is about 13 miles wide. Not quite as wide as the Grand Canyon, but it's twice as deep. Sunlight never reaches the crater floor, so temperatures there are around 300 degrees below 0 Fahrenheit. This model of the terrain is made possible by Lunar Reconnaissance Orbiter, which has been mapping the surface of the moon from lunar orbit since 2009. LRO's maps will be incredibly important for exploring the moon and locating water and other resources there.
That's the topology of the South Pole of the Moon. Imagine these craters never having seen sunlight in billions of years. And this brings us to the topic of, believe it or not, water, because a lot of water has been discovered, not just at the South Pole, but at the North Pole of the Moon as well. Now, these are just some of the spacecraft that have detected it. Lunar Prospector, I think, was the first in 1998, and it detected a possible 300 million tons of water at each pole, so 600 million in total. Then we got Clementine in 1994, detected water at both poles. Chandrayaan-1, the predecessor of Chandrayaan-3, which is hopefully going to land on the moon on Wednesday, was an impact mission to slam an impactor into the moon, and it detected water ice near Shackleton Crater. The LCROSS mission from NASA, again another impactor, detected water ice near KBS Crater, another crater at the south pole of the moon. The Deep Impact mission, you may remember, to NASA's wonderful mission to ram a probe or an impactor into an asteroid, and that was in 2009. But on its way to the asteroid, it bypassed the moon, and it actually detected water vapor in the moon's atmosphere. And if you're going to turn around and say that the moon hasn't got an atmosphere, well, yes, it has. It's just a very, very thin one. But the Deep Impact mission detected water vapor in that atmosphere. And Chang'e 5, you may remember, I think I reported on this a couple of weeks ago, that around impact sites on the moon, around craters, in other words, it found all these glass beads laying about on the surface that were full of water. So there may be a huge amount of water locked up in those glass beads around craters just on the surface of the moon. So these were all momentous discoveries. Now, the NASA flying observatory, SOFIA, which, as you may know, was in a modified 747, an infrared telescope, looked at the south pole of the moon, and this is what it saw. And you can see here that this is basically telling us that this is water, and lots of it at the lunar south pole. So this is all very exciting. Now, if you can get at that water, well, what does it do for you? What would you use it for? Well, astronauts would use it for all sorts of things, but they would use it obviously to survive, for life support. They would use it for hydroponics, to grow plants on the moon. And they would use it for rocket fuel, because you can split the water into oxygen and hydrogen and make rocket fuel out of it. And of course, they would use it for research, general research about the moon. But there will be other things, I'm sure, that people will think of as well. So it's very, very interesting. Where does the moon's water come from? Well, a few possible places. Comets and asteroids is obviously one, but the solar wind is another, because the charged particles from the sun interact with the lunar surface and can create water molecules, believe it or not. And it can also be from the Earth itself, because don't forget, we believe that the moon was formed after a Mars-sized body collided with the Earth early in its history, and a huge amount of the Earth's crust was thrown into space and then coalesced quite quickly, as it turns out, to form the moon, while the water could have come from the Earth in that way. We don't know, basically, is the answer. But then again, we don't really know where Earth's water came from in the first place. So there we are. So that's a bit uncertain at the moment. So a few possible origins for that water from the moon, but I think a lot of it primarily will come from comets and asteroids. Now, how do we get there? Well, actually, as Lunar 25 found out this week, landing on the moon's south pole, or the north pole, come to that, is not easy. But actually, landing on the moon generally is not easy. 50% of all attempted landings on the moon have failed, and you may know that that's exactly the same failure rate as Mars, funnily enough, in a weird cosmic coincidence. So what you have to do, you have to put your spacecraft into a normal, inverted commas, orbit around the moon, a non-polar orbit, and then over time slowly change its orbit so that it becomes a polar orbit. Sounds easy, but actually it's quite complicated. And the loss of Lunar 25 appears to have occurred during this crucial phase of changing the orbit into a polar orbit, ready for landing. We don't know exactly, but it looks like that's what happened. So it's not easy. But if everything goes well, this is the place on the moon in late 2025 where NASA will land. And it's been chosen in close proximity to Shackleton Crater, which, as we saw, has got lots of water in it. So hopefully astronauts will descend on SpaceX's Lunar Starship towards the moon's south pole and land on this sort of mountainous region here, which is called Malapert Massif. It's thought to be actually part of the rim of the Aitken Basin, that massive impact crater basin that is mainly on the far side of the moon. But the Mount Malapert Massif is thought to be part of it. And hopefully in 2025, this is where NASA will land. Assuming that everything goes well, they want to get at the water. So how do we actually extract ice and water from the moon? Well, you've got a number of different options for getting it out. You can scoop it with a robotic arm, but it turns out that's not very efficient and certainly not energy efficient. You can use a laser to vaporize the ice and then collect the water vapor. That I think would be a little bit tricky to do, but it's one option. You could use a heat exchanger to just melt the ice and collect the liquid water. And there are other methods they're looking at, including just straight drilling, something called electrodialysis, and heating the ground with microwaves to release the water held up in it. But there are lots of people working on this. So by the time that humans are ready to start mining the ice on the moon, then hopefully we'll have a good method of doing so. And lastly, talking about the race to the South Pole, well, we've got all sorts of countries involved in this. India, of course, Chandrayaan-3 is going to land on Wednesday, all being well. Fingers crossed. Hope it goes well, India, because God knows you need a success. They're also looking forward to the future, to Chandrayaan-8. I don't know why the numbering has changed so much, but it's scheduled to launch in 2025. And like Chandrayaan-3, it will consist of an orbiter and a lander and a rover. And they're going to conduct a detailed study of the lunar South Pole, including the search for water, ice, and other resources. The USA has got the Artemis project, and it's all mapped out. Artemis 2, an uncrewed mission to fly round the moon, much like Apollo 8 did in the days of Apollo in 1968. Artemis 3 will be the first mission to actually land people on the moon, the first woman and the first person of color. Artemis 4 is going to deliver the Lunar Gateway. This is a space station that's going to orbit the moon and be used as a staging post for future Artemis missions. Artemis 5, that's going to launch in 2027, and they're going to stay on the moon for a much longer period to carry out experiments and collect more samples. Then we've got Artemis 6 in 2028, delivering a habitat module to the Gateway. Artemis 7 launching in 2029, where the astronauts will stay on the moon for even longer to do valuable scientific work and collect and analyze more samples. China has got the Chang'e 7 mission scheduled to launch in 2026, consisting of an orbiter, lander, and rover, and a small flying detector. Not quite sure what it's going to be detecting, but I suspect it's ice. And again, it's exploring the lunar South Pole for evidence of water, ice, and other resources. Chang'e 8 in 2028. This is going to actually try to extract water from the lunar surface using what's called, and it's a whole acronym, ISRU, which stands for In Situ Resource Utilization. Why can't they just say mining, for God's sake? Because that's what it is. Chang'e 9 in 2030, and they're going to land astronauts. China's going to land astronauts on the moon near the lunar South Pole. And beyond 2030, China is in partnership with Russia to develop the International Lunar Research Station, a permanent base at the South Pole of the moon. And actually, there are quite a few Western companies already helping China get this thing ready. So it's definitely a goer, although Russia's role in it is a bit in question now, especially after the Lunar 25 loss this week. So we'll have to see what happens there. And of course, we'll keep you posted. Others, Japan is planning to launch a mission to the lunar South Pole in the 2020s. It's called SLIM. This is a much nicer acronym, Smart Lander for Investigating the Moon, which I like. That's short and sweet and to the point. South Korea are planning to launch a mission to the lunar South Pole in the 2030s. That's a little more of an unpronounceable acronym. It's KPLO, KPLO, the Korea Pathfinder Lunar Orbiter. UAE, the United Arab Emirates, is planning to launch a mission to the lunar South Pole in the 2020s. That's called Hope Probe, because their Martian mission is also called Hope, of course. India and Japan have a plan to develop a mission called the Lunar Polar Exploration to explore the poles on the far side that we can't see directly from the Earth, launching before 2026. So that's a nice international collaboration. Just a word about legalities of all this. The Outer Space Treaty, signed by all spacefaring nations in 1967, specifically says outer space, including the moon and other celestial bodies, is not subject to national appropriation by claim of sovereignty, by means of use or occupation, or by any other means. Basically, it means no country can claim all or part of the moon, that it's there for the benefit of all humans. So China, for example, couldn't set up a lunar base and then claim territory on the moon. This has never, as Daz and I were saying earlier, this has never really been tested. It's still in force, the Outer Space Treaty, but whether it would actually work in a court of law now,